Hey everybody, welcome to Science with Mueller. Today in our whiteboard series, we're talking about vectors. So let's get into it. We have two key points about vectors. First, always resolve vectors into components. So if they are not pointing either straight up and down or straight left and right, or they are not in reference to some other object and they're perpendicular, we are going to resolve them into components. That's just what we're going to do. We're going to find the horizontal and vertical components of all vectors in a funny direction. The second thing we're going to do is when we are finished resolving components and we want to put them all back together into a single vector, we're going to use two equations. We're going to use the Pythagorean's theorem, solve for c, that's this one right here, and we are going to use the inverse tangent function to find theta right here. We're going to use those two equations to help us solve and put our vectors back together at the end. So let's get into some examples. All right, so we're going to start off with some vector components. So here we have a lawnmower. You're pushing on the lawnmower with 20 newtons of force at an angle of 35 degrees. So how do we take that lawnmower and turn it into vertical and horizontal components? So here's how we're going to do that. First, I'm going to just look at my kind of vector area here. I'm just looking over here and I want to draw a little picture here. So I've got, here's my starting point of my vector. We'll keep things together and it's in red here. There we go. And I'm kind of coming down this direction. Okay, so there's my vector f. I know it's got a length of 20. And then I know that I've got this angle measure from down here of 35 degrees. So my two vectors, my components, are the horizontal and the vertical pieces of it that make a right triangle. So I can say I'm going to come down first, and then I'm going to go to the right to get to the end, because so that's how we always draw our vectors, is we're going to have a vertical component and we're going to have a horizontal component. Oftentimes, so this vector was called f, we will call the vertical component f sub y, and we put that subscript y to indicate it's the vertical component, and we're going to do f sub x to indicate that is the horizontal component. So how do we find these vertical and horizontal components? What we're going to do is use some trig values, okay? And so we need to remember what our trig identities are. So we can use SOH, CAH, so Ka, and TOA, TOA. And those are going to help us remember our trig identities here. So what we need to remember here is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And these are going to be our big ones to focus on for this particular one. So we know the hypotenuse here is 20. So our f sub y component, let's start with f sub y. This is our opposite function. So f sub y here is on the opposite side. So that means we're going to be using this sine function because f here is hypotenuse. So we're going to use sine there. So what we can do here is we can say that sine, and we're going to do a little, I'm going to scooch, we're just going to do a little work over here. So we can say that sine here, sine of our angle measure, so sine of theta, is equal to opposite over hypotenuse. So it's going to be fy over f20. So we're going to f sub y divided by capital F. And if we solve for fy here, we end up with the equation f times sine theta. F times sine theta. So now we have a nice little equation for that. This would actually be a good equation to put down in your notes somewhere, to have on a cheat sheet if you have it for your quizzes and tests, because we're going to use this equation a lot in order to find the y component. For the x component, we're going to use cosine. Cosine of theta is going to be equal to adjacent over hypotenuse. And so f sub x is on the adjacent side. So we're going to use cosine theta is going to be equal to f sub x over capital F. And if we solve here, we're going to see that f sub x is equal to f times cosine of theta. And again, another equation, super handy for us to have, okay, when we are doing our vector computations. And so now we can take those two equations, we're going to run them over here a little bit, and let's figure out what the value of our two components are. And all we have to do is plug and chug in the values we need. So f sub y would simply be 20 times sine of my angle measure. My angle measure here is 35 degrees. Make sure your calculator is in degree mode, not radian. And f sub x, let's do that in purple here. F sub x would be 20 times cosine of 35. So we'd punch those into our calculators and see what values we get. So let's come back here in a split second to get those values. After some quick math, we can see that f sub y is 11.472 approximately, and our f sub x is going to be 16.383. And there we found our horizontal and vertical components for this particular force vector. Let's go to our next example. All right, so in this problem, we're given a box. There are two forces acting on the box. One that's horizontal, that's vector A, and one that's vertical, vector B. And they are at 90 degrees from each other. Vector A is 10 newtons of force and vector B is 7 newtons of force. And so the question is, what's the net force in the box? In other words, what's the resultant when we put these two vectors together? So when I want to take two components, so here we have a vertical component and a horizontal component, I want to put them together, I'm going to use key point number 2. So key point number 2, we have two equations we're going to use. One is that c is equal to the square root of a squared plus b squared. This is part of Pythagorean's theorem. The second equation we're going to use is that theta is equal to tangent inverse of opposite over adjacent, Opposite over adjacent. Those are the two equations we're going to use. Let's start with that first equation there. So in our first equation, remember, this is Pythagorean's theorem. A is a leg, B is a leg, and C is hypotenuse. So A and B are interchangeable here. So let's go ahead and let A be A and B be B. So if we plug in our values into this equation, now that we've already got our components solved, it becomes a very easy problem. And so we take 10 squared plus 49 squared, and we just punch it into our calculators. So let's go ahead and do that. Punching it in gives us 12.02. 206. I mistyped that. There we go. 206. And I like to keep 3 decimals to make sure I don't miss anything with rounding. You could also write this. You could also write this 207, but that is up to you. All right. So again, we're just plugging and going here, plugging and chugging. Same thing down here with the inverse tangent. So to get our angle measure, we just plug in our values. So we're going to do tangent inverse of our opposite over adjacent. So here, if we think about our triangle, we need to redraw our triangle a little bit to kind of think about where this is. So if we have our point right here, we've got our horizontal vector going this way, we have our vertical vector going down. We can draw our line like this. And so it doesn't matter how you draw this line, or I guess it does matter. You're either going to get this angle here or you're going to get its complement. So if we were to come down this way and come over this way, you would get its complement. So these two angles here, the purple and the orange, would add up to 90 degrees. So you just need to be careful on how the problem asks. This top angle would be for if you want it with respect to the horizon. So this would be with respect to the x-axis. And the bottom one there would be with respect to the y-axis. So you just got to ask your teacher which they prefer. Most of the time we prefer the first there with respect to the x-axis. And again, that's because a lot of times we measure things from the ground. So we're going to go with this one today. So here, if we look, the vertical vector is going to be opposite, and the horizontal vector is going to be adjacent. So then we're going to go ahead and put those into our fraction here. So the vertical component, that's B, that's got 7 newtons there. So we put the 7 on the top. And the horizontal vector, A, is a power of 10. So we put 10 there. And now we just punch it into our calculator and get a number. and I got 34.992 degrees here. And so the net force of our box, if we were to put this into a final answer, is 12.206 newtons at 34.992 degrees. And there we go. We've found the resultant vector after having two vector components. Now we're on to our last problem. This would be an example of one of the harder problems you might see in a high school physics class or an introductory physics class at college. So here we have a boat. It's being pulled out of the water by two friends. One friend is pulling at 50 newtons at 45 degrees. That's person A. Person B is pulling at 40 newtons but at 30 degrees. So the question is, what's the net force on the boat? First step is we need to resolve both vectors into components. So off to the side here, I'm going to first do my components here. So I'm going to do vector A, and I'm going to do vector B. We'll do A first here. So if I think about A, I'm going to redraw that picture here. Okay, so I've got my A is pointing off in this direction. It's got a length of 50, and it's at an angle measure of 45 degrees. And I'm going to kind of pencil that in there really small, and that's okay. And then, so now I can draw my two components. And it's really important that we draw these components here. So we're going to have the bottom component here. That's our horizontal one. That's A sub x. And then we're going to have our vertical component here, A sub y. And so here we're going to use those equations we had from earlier in order to figure out what A sub x and A sub y are. We're going to do the same thing with B here. So with B, again, our vector comes down kind of like this. And so we are at 40 newtons of force at an angle measure of 30 degrees. So again, I draw my two components here. So I'm going to have my horizontal one, that's B sub x, and I have my vertical one here, and my vertical one of B sub y. And again, I'm going to use my equations from earlier to find out what A sub x and A sub y are. So like from before, my equations are right there on the screen now. So A sub x, any of your x components are going to be the vector value, A in this case, times cosine. Any of your y components are going to be the vector length times sine. So I'm going to go ahead and plug in my numbers here for each of these vectors just to show you where those are. So on this first one, I'm going to use my A values here. So I'm going to use 50 cosine of 45. And here I'm going to use 50 sine of 45. On the bottom here with B, I'm going to do 40, and I'm going to use my other vector or other angle measure of 30. So I'm going to use 40 cosine of 30, and I'm going to use 40 sine of 30. And we're going to go ahead and punch this in our calculator to get some numbers here. Alright, so I punched those values into my calculator and I got these numbers here. Take note that the values for AX and AY are both 35.355. The reason that they're both the same value here is because of the angle measure is a 45. Okay, whenever you have a 45 degree angle measure, the legs are going to have the same length. So what we can say here, and just to really iterate this, make sure everything is crystal clear, is that this length here is the same as this length here, despite how my drawing is. Okay. All right. So we got those. On B, we have an angle degree of 30. So that means our sine is going to be a little smaller. 34.641 for our X component and 20 for our Y component. So let's go to the next step. So our next step here is to combine like components. When I say like components, I'm going to put those in just quotes here. What we mean here is that they have the same direction. So horizontal components are in the same direction, and vertical components are in the same direction. So that's what I'm going to add here. So I'm going to make two columns here. I'm going to make my horizontal and my vertical. And then I'm just going to add the values there. So if I think about it, what are my horizontal components here? My horizontal components are AX and BX. So I'm going to add those two together. So I'm going to put AX and BX together under my horizontal. If I think about my vertical ones, my vertical components are BY and AY. Now, I do have to be a little careful here. look at the directions of on my pictures here. BY is pointing down. AY is pointing up. Those are opposites, so one of them has to be negative. I'm going to go ahead and make my down one negative. So here under vertical, I'm going to say that AY is minus BY. And what those are going to do is those are going to give you the net change, or the net component in the X direction and the net component in the Y direction. Let's go ahead and plug in our numbers and run them through the calculator and see what we get. And we get 69.996 and 15.355 for our two respective components. So over here we have our X component here. I'll just mark that as a big X here. And over here we have our Y component. So we have those two values. So this leads us to our third step, which is to redraw the triangle and find our net component. All right, so I've redrawn my triangle with now X, Y, theta, and net. So again, we're very close to our final answer. We really want to know what's net going to be and what's theta going to be. Those are our two final pieces we need to have in order to figure out what's the total force on that boat. So the way we're going to do this is we're going to sub in our X and our Y, and now we're going to use the Pythagorean theorem and the inverse tangent function in order to find our values. So remember, X here was 69.996, and that's what we calculated from step 2 by combining our vectors. Our Y value was 15.355. And again, that came from earlier where we combined our Y components. So now we can use our equations here. I can use the C is equal to the square root of A squared plus B squared. And I can use theta is equal to tangent inverse of opposite over adjacent. Okay. I'm going to punch in my numbers here, get some values, and then close things up. So there we have it. We punched in our numbers into our calculators. For the Pythagorean theorem, it does not matter which one you pick for A or B. They're both legs of the triangle. For the theta, it does matter. We're going to use opposite goes in the numerator. So in this case, that's the 15.355. And then we're going to use the 69.996 in the denominator for adjacent. We get 71.661 for our magnitude of our vector. So that's the length of it, how much force is there. And we get 12.373 degrees for the direction, and that would be from the horizontal. And so there we have an example of how we would go through a vector problem with multiple vectors at funny angles where we want to know the resultant vector. Again, to summarize into 3 steps, break them down into components, combine like components, and then redraw components and find the net vector. Hope this video helps. Don't stop learning.